Triangle ABC has three acute angles, and we're going to use SOHCAHTOA to determine the length of BC. But to use SOHCAHTOA, we need a right angle triangle. This triangle is not a right triangle by itself, but we've split it into two. We've got triangle ABD and triangle ACD. Alright, and so we want to find side BC. We are going to do that in a couple of parts. First part, we do have triangle ABD. It has an angle of 20 degrees. We have a hypotenuse, and we just need to find this part right here. I'll call it O. O for opposite. So it's going to be sine 20 is equal to your opposite over your hypotenuse, which is 12.5. And when you multiply this together, you'll find that opposite is going to be 4.275, and that's BD. In the second triangle, we have two angles, but unfortunately we have no sides. That kind of stinks because we need at least a side in order to use the SOHCAHTOA formulas. Okay, but we can find this side that I've highlighted here in green, that's side AD, using the information from the older triangle we just used. So that would be your adjacent. I would highly suggest sticking with the hypotenuse when figuring this out. So we've got the adjacent and the hypotenuse. That's going to be cos. So it's going to be cos 20 is equal to, we'll call that A, adjacent over your hypotenuse, which is 12.5. So when you work that out, cos 20 times by 12.5, A is going to be 11.746 centimeters. Last but not least, of course, we want to find ultimately DC. We do have a side now because of that A. We do have a couple angles. Now, I'm going to use tan. I'm going to say that this is, of course, your opposite because we're going to use the angle 55 right here. We have our adjacent, and all we need to do is find that opposite. Okay, so it's going to be tan 55 is equal to your opposite over your adjacent, which is 11.746. And what you should get when you work this one out is going to be 16.775. Okay, so when you add these two up together, what you should get to two decimal places, BC is going to equal 21.05 centimeters.